Hello and welcome to day 13 of Advent of Code 2024. So today we have a puzzle including claw machines, which are basically visualized as a machine where you have to normally steer a claw and then place it exactly over an item to see if the claw can pick it up. So in this case, this claw machine here, they don't have joysticks. So they only have two buttons labeled A and B, and there's also costs involved. So to push the A button costs 3 tokens, and pushing the B button costs 1 token. So what you have to figure out here in this puzzle is if it's even possible for this machine to win a prize, and then also how many presses does it take, i.e. how many tokens does it cost. So you can see here in this test example here, we have the buttons are indicating by an X and Y coordinate, and yeah, so this means that when you push the A button for this example, we will increase the claw on the x-axis with 94 and on the y-axis by 34, and the same similar with the B, and the price X and Y coordinate that tells us where the price is. So we need to find that out in some way. So we will have the final question here is that what is the fewest tokens you would have to spend to win all possible prizes? So right, yeah. So we will check out how that can be done. So in this case, I have kind of added a little bit of boilerplate code to my sketchpad here, because don't need to write all this code. So first thing you have to think about when doing this is obviously to parse the input file, and that's always the first thing you do with AOC problems, and this time it becomes a little bit more tricky. So basically, I will just read in all the texts, and then I will split that text up by the double new line. This gives us the list of string, and this so in this case the string on each list item here will contain one of these sections. So yeah, sorry about that. So each of these sections will be in our string. And for convenience sake, for this problem, I created a class to represent this claw machine. So we have a button AX, button AY, and button BX and button BY, and the price Y and X and Y coordinates, and also the costs involved with pressing those buttons. So so what we want to do is we want to parse this. We will do that in the class constructor. So that constructor will take in the string, like maybe we can call it the machine config or something. So here we now have that chunk of machine config. We want to split that up. So we create a splitted config. We take the machine config and split, well, not by double new line, but by split by new line. So if you're wondering about these split by double new line and split by new line, this is just helper functions that I have in my AOC library, which basically does what it says. I mean, you can achieve the same thing yourself, of course, but it's just for a little bit convenience when doing these kind of problems. So we want to have the as you can see here for the input, we see that for each of these lines here. So when we parse by a single new line, we will get one line with this, one line with that, one line with that, and we're actually just interested by the numerical values for each of these rows. So what we can do then is to take. So I will create a parsed button A, which will be our splitted config. And then I have another helper function called parse ints, which will run a regular expression over that row and collect all the numerical values. Then we will have our button B and our price as well. So we take our button B, will be our second. Take our button C, which will be our third. So then it's just a matter of setting those button AX will be parsed button A0 index. Then we do button B as well. And then we will also set the price as well. So price X will be, well, there are no, yeah, okay, I did, so it should be parsed price, of course. Price and price Y will be, yeah. So that's it. Yeah. So that will give us the parsing. So we can now do our. So we can now parse our list of claw machines. So we will call it claw machines, and we can do it like this. We should do a numerable range. The range will be from 0 till input count. We do a select, like we have the I, for instance. Then we will do a new claw machine, sending the input indexed by I, and it will be a list. Yeah. So so now we need to have some kind of method in this class to calculate the tokens required to reach the price, if even possible. So so we should have a method. It will be public long, because this value could be large. So it should be a long called calculate. Oh, my spelling is really bad. Calculate tokens required. Yeah. So we set it to return 0 as of now. So we will actually do the so we have fewest tokens will be equal to our claw machines sum. So yeah, and we will also have our part 1 answer after this, which will be our fewest tokens. Yeah, so when thinking of this, thinking about doing this, I first actually thought about doing some kind of simulation for this, but when I looked a little bit closer to this, I kind of saw that this is some kind of math problem, and you can actually solve this with a real simple linear equation. Although I'm not that skilled in math, and not sure I can explain it in the right way, but I will try anyway. So this is how I did it. Now I basically checked some old code, and I found a previous example that I did previously, and it contained about the same type of code. So I was fortunate that way. So we will have our denominator, which will be our button AX times button BY minus button A. It should be button A y times button b x, of course. Just that will be our denominator. So this is just basically to find if it's even possible to so this denominator calculation actually takes out the coefficient of the linear matrix. So we will also have our long numerator, which will be price y, actually, price y times button a x minus price x times button a y. Yeah, so that will be our numerator. So now we need to determine if our equation can calculate the number of times it actually takes to press both button B. We will first check the button B, then we will check the button A to reach the price. So we will do that by another equation or another calculation. So that will be of type double in this case. We will do button B presses will be like the double value of the numerator divided by the denominator. Oh, sorry about the background noise. It's my dogs are hearing something. Yeah. So in this case, the button presses in this case will obviously be a double, so it will be a decimal value. But we want to be able to get to get to the price with button B. That value needs to be an integer or a long, be parsable to int or long. So that's then it must be a whole number, so to speak. So I fortunately had such a method, such an extension method. So I can just say is whole number like that. But it will basically check that this is parsable to a long or int, depending on what you want. So if it's not a whole number, we will not be able to reach the price with this machine. So then we just return 0 in this case. So now we will calculate the button A presses, or how many presses for the A button that's required, and that will be another calculation, which will be price X price X, so we will have minus button BX will be multiplied by the button B presses divided by button AX. This is basically the whole equation needed for this problem. So we will do the same thing for our button A presses. So if it's not a whole number, we will return 0. And otherwise we will actually return the value that you want. So it will be type long. So it will be the button A cost times button A presses plus the button B cost times the button B presses. So this will basically be it. So if we run this, we should get the correct answer. Yeah. So 480, I think that was what they were after. Yeah, 480 was the test value, or the example input value. Okay, let's check out part 2. So so in part 2 here, we will obviously need to go a lot further. So this kind of tells you that if you had done a sort of simulation solution for part 1, this would not have worked, because it would be such a long loop that you wouldn't have to, it wouldn't be possible to run it, I think. So so for part 2 we need to add this long number to our price coordinates. So what we do here, what we do here actually to fix for part 1 is, or part 2, I mean, is that we add one more constant, which would be a decent large number. We will also add boolean to our constructor. So if is part 2, set it to false by default. So we want to have an if statement around this. So if is part 2 and else should proceed like before. So in this case we will just add the price offset. So we can use the same type of, we can use exactly the same equation. The only difference is that we will add this large number to our price coordinates. So we will just can just do like the fewest tokens will still be the claw machine's sum of, yeah, well, it's a little bit faster, but calculate, no, of course we cannot, we must also reparse the claw machines as well, because, and adding this new value. So we reparse our claw machines, take this gonna do it again. Add just true for the part 2. Okay, what's the, yeah, of course, that needs to be inside this constructor. Yeah. So now we will have our part 2 value. So part 2 will be that. Let's run it. Now we will have this large value instead. Let's validate. Yeah, they don't actually tell us what this test value should be, but it's just to prove, I will just run it with my real value, and we can compare it with that. Now we have our real value 8102. We can check 8102 in the end. So that's basically how you solve the day 13 of Advent of Code 2024. So it's nice to have. Now we have had some simulation problems lately, so it was kind of pretty high odds to have a math problem today. So let's see what they bring for us tomorrow. This is the weekend. Could probably be a real hard one, maybe. So let's see. But so this is all from me from today, and I hope to see you again tomorrow then. Bye bye.